What's Kilauea doing now? Well, the bullet points are here coming up. First of all, magma is returning to the East Rift Zone and to the summit area of Kilauea. And that's best shown in this interferogram, which is a graphic produced from one of these radar satellite imagery passes I talked about. Two passes compared, and these psychedelic fringes here are bullseye patterns, are basically showing an area of uplift. Take my word for it, that's the way that these radar images get combined to show that process. And you see the bullseye right over the Kilauea summit, because the ground there is rising slowly as magma is coming back into the system. And also down here, here's Pu'u'o'o in the Middle East Rift Zone is also rising as magma is accumulating in the summit. The accumulation area in the East Rift Zone actually extends down towards Highway 130, which is just right at the edge of the slide here. So it's really a broad region in the Middle East Rift Zone that's inflating or reflecting this accumulation underground. Another important point about Kilauea right now is that the gas emissions are at the lowest level they've been in a long time. Just last week we measured only 40 tons a day of sulfur dioxide coming out of the summit. In the lava lake time, the numbers were up around 5,000 tons per day. So the magma is deep enough that we're not seeing a lot of sulfur dioxide at the surface. We can see that same process if we look at the GPS data for the summit of Kilauea. This is a station up near the old observatory. And this is a plot going back from February of 2018 to today. Basically focus on the fact that there's an upward trend to this plot. This shows that there's been about 15 centimeters of ground uplift. So what's that? It's about 6 inches or so uplift of the ground over at the old observatory as the summit is reinflating. And the same thing out on the East Rift Zone. These are other stations, this one near Pu'u'o'o, this one a little further down rift. I should have pointed out that this big drop here is to the eruption in 2018 when things were collapsing. Pu'u'o'o is up about 20 centimeters and Joka up about 10 centimeters. So the volcano is reinflating, meaning magma is coming back into the system. The other big change at Kilauea that many of you are aware of is that we now have water in the summit of Halema'uma'u, or the summit crater, the Halema'uma'u crater. And here's a photograph from one of our web cameras that you can find on our website. Showing the new collapse region with a little, well, it's not little, it looks little because it's so far away, but this is the rising lake of water. I'll tell you how big it is in just a minute. This is a plot of the depth of that lake of water from late July up to just a few days ago. It's now 75 feet deep. And the lake itself is this big, it's 280 feet by 620 feet. So it's a football field wide, 2 football fields long, and of course it's getting bigger all the time, rising still at about a yard a week. This is a video, a sped up time lapse from a camera that was positioned on the east rim of the inner pit when our crew was down on the down drop block recently. And of course it's much faster than real, but it's showing some interesting things, the steaming of the surface. You can see some motion of the cloudiness in the lake. You can see that some areas are greener than others. These greener areas we think are areas where fresher water is coming into the lake, and then it's being mixed with minerals that are precipitating, causing the reddish brown color. It's a very dynamic lake. And it's hot. So this is a thermal image taken from the helicopter, but this is what the image is showing here is temperature of the lake. It's about 70 degrees centigrade, so that's 158 F. That's just about scalding. And that seems to be a pretty constant temperature of the surface of the lake. It's probably hotter with depth. So what's going on with this lake? If you can come to Matt Patrick's talk next week, you'll hear about this in great detail. But in a nutshell, here's what we think is happening. Back when the lava lake was active, of course, it was very hot. There was 2,000 degree Fahrenheit lava coming up to the lake. And it basically was forcing all the liquid water into steam or away from that conduit system. And so the water table was back. And there was no liquid water reaching the conduit. Well, in 2018, the lake drained. The summit fell in. A big deep hole got punched down and basically intersected the water table, which has now returned because the heat has changed. It's not so hot anymore with that column of magma. So that's what we think is happening. And one question, of course, is how deep do we think it could get? If it becomes as deep as water in a research drill hole, it's about a mile to the south of the lake, this dotted line shows how deep it might get. So that's going to be a pretty significant water body. Unfortunately, you can't see it unless you're really right on the rim. But we've got a lot of web cameras looking down there, so you can watch it. We did sample the lake water, which of course is something lots of people were interested to do. We used an unoccupied aerial vehicle in late October with park permission to do this, and we've sent the water off for analysis, and these are some of the things we learned. First of all, it was a very atypical lake for volcanic crater lakes. We expected it to be quite acidic, and even though it is acidic, a pH of about 4.2, a lot of volcanic crater lakes are closer to 1 or 2. And we think that's likely because it's reacting with some of the lava rocks along the bottom of the lake and the walls, and it's being buffered somewhat. It appears to be groundwater or rainwater leaking in, as we suspected. There's a lot of volcanic gas getting dissolved in this lake, and we see that in the sulfate chemistry, as well as some of the precipitates that were brought out of the water in the lab. The water is a little different than the Keller well water, which is to the south, the research hole, and we're still trying to figure out what that means. It's probably a mixing with waters along that path from the well to the lake, so it's not exactly the same. And the gases in the atmosphere around the lake were actually not too high. Carbon dioxide and sulfur dioxide concentrations were not great. A lot of that gas is going into solution in the water. So what we want to do now is keep sampling with some periodicity to watch for changes in that lake chemistry. Of course, another really important question is what are the hazard implications of having a lake inside Halema'uma'u? The presence of water, whenever you're talking about hot magma potentially interacting with that water, do allow for the possibility of explosions. But we think at this point we won't have explosions from magma-water interaction unless magma rises very rapidly into the lake. And we see no sign of that happening, and we would expect to see changes before that happens. And even then, we're not sure, given the geometry and the volume, that there would actually be explosions. But it is a possibility we have to consider. Especially after the New Zealand eruption a few weeks ago now, people have asked if that could happen here. And our answer is that it's a very different system here. This is a much leakier volcano. There's no sign that the system is sealing and pressurizing under some sort of impermeable cap, like happened at that White Island volcano in New Zealand. Our volcano is not at this this water lake is not at sea level. It's got a different composition. The rocks are of a different chemistry, so the minerals precipitating are not high in silica, and they're not likely to clog up the pore spaces in the same way. So the short answer is we don't think we have a White Island situation developing here. But we can't completely rule out the possibility that there will be sudden steam explosions at some point. So this is something we're considering as we go forward. So what's next at Kilauea? Well, magma is returning to the system. That we know for sure. But it's still possible we'll have many years of quiet before the next eruption. Many years, a year, 5 years, hard to say. Based on past patterns following big events like 2018, it's most likely that the next eruption would be in the summit area. That's about all we can say with certainty.